All right, stats enough for this gathering data. Here we go, section 6.3. Some review. Much of what we're about to do is based off of the binomial distribution, which we took a chapter test on already. The binomial setting had 4 characteristics. Number 1 was the binary characteristic, or sometimes I call it binomial. Every trial or event can be thought of as a success or a failure. Number 2 was the independent condition. And that went like this. One trial doesn't affect another trial, so the probabilities don't get affected because of what you did with the first trial. Number 3, n is for the number. There is a set number of trials in whatever I'm doing, and we call that number n, of course. And number 4, success. The probability of success is the same for each trial. That's the word same. That's what I meant to do. I meant to write that word right there. Okay, so I go through the light at 38 and 47 every morning on my way to work. I'm just trying to get to this is, I used to say Subway, but Subway's not open in the morning anymore. I'm so sad about that. And then to my classroom before 7:30 so I don't get yelled at. Every day there's a 15% chance that I'm going to hit a green light when I get to 47. If we consider every trip to school to be independent, the question of whether or not I'll hit a green light every day for a 5-day week is a binomial distribution. It's a discrete random variable instead of a continuous random variable. So here's the distribution, okay? If I'm going 5 days, I could get 0 green lights all the way up to 5 green lights. And here are the ways that we can find each probability. You guys have already done this once. It goes like this. The probability that x is equal to 1, saying that one day out of those 5 days I get a green light. It would go like this. 5 choose 1 times 0.15 to the 1 and 0.85 to the 4. That's how that would go. And I get 0.3915 if I put all of that in the calculator. And so I go up to 1 and I put 0.3915. All of these have to add up to 1, of course. The other way I could do this, if I wanted the probability that x is equal to 1, is with a binomial PDF. The PDF is the one that gives you just for one thing, and that would be 5 and 0.15 and 1. Put that in the calculator and you get 0.3915. Now if you don't remember where this is, you hit the second button on the calculator and then you hit the variables button to get the distribution menu, and you scroll all the way down until you find the binomial PDF and CDF. Now in this case we wanted the binomial PDF. Alright, so there's some review for you to start about binomial variables and such. And so I'm going to go to the second page, still doing review stuff, and I want to fill in every single one of these numbers. Okay, so I did all these so you guys don't have to because it is review. The probability that I don't get any green lights whatsoever is 44%. This is 0.3915, 0.1382, 0.0244, 0.0022, and the last one is so small I'm just going to write 0 because it's past 4 decimal places. So for the distribution that went B, 5 days and 15% chance of getting a successful green light, there are all of the probabilities. Now we learned more about this distribution as we went along. You can find and interpret the mean of the binomial setting where n is 5 and the probability of success is 0.15. The mean went n times p, and I would go 5 times 0.15 and get 0.75. The interpretation, after many 5-day weeks, oops, misspelled that, I would expect an average of 0.75 green lights for every 5 days, right? Okay, the standard deviation, that went the square root of n times p times q. Now this is all going to come back into play here in section 6.3. That would be the square root of 5 times 0.15 times 0.85 If the probability of success is 15%, the probability of failure is 85%. That's where that comes from. That's 0.7984. Interpretation. Okay, I'm going to do it again. After many 5-day weeks, I'm just going to write after many weeks. I think you guys get it. After many weeks, we expect the number of green lights to differ from the mean of 0.75 by an average of 0.7984. We've written that so many times, we got to be getting tired of that. Okay, now to get to the point for section 6.3, we need to notice something. Okay, that actually happens with some histograms. So for a large part of the notes today, we actually need to make some histograms using our graphing calculators. All right. We need to see a histogram for each of the following distributions. The binomial distribution with 5 and 0.15. Now that's a representation of a 15% chance of getting a green light and going 5 days in a row. The binomial setting with 10 and 0.15. Well, that's the same scenario, 15% chance every day, but for 10 days. We're going to do this again with 25 and 15 for 25 days. And we're going to do it once again for 50 and 0.15 as if I were keeping track for 50 days in a row. And we're going to make a histogram for each one of those things. I don't even want to make a histogram for this one with these 6 bars right here, and you don't either, but we're probably going to. So let's flip the page, and let's see how we can get the calculator to help us out a bit. It would take way too long to find all of those probabilities. I mean, think about it for just a second. If you start with X and you get, if we were going all the way up to 50, you would have 51 probabilities here. You'd have to find all of them to make this histogram. It would also take way too long to make all of these histograms by hand. Yeah, imagine that. Not after you find those things, you actually have to make 51 bars. So, calculators. We're going to use the calculators. Okay, for the binomial situation with 5 and 0.15, as if I'm checking this for 5 school days with a 15% chance each day. All right, you know what? I'm going to write it all down, and then I'm going to go through it, and we'll do it on the calculator. All right, first go to your lists and clear out list 1 or list 2. Okay, I'll do that one first. I'm going to go to my lists, so hit stat, and then you go to 1 for edit, and anything is there, we want to clear it out. So you arrow up, hit clear, arrow down, it disappears. Arrow up, hit clear, arrow down, it disappears. Okay, now this is what we're going to do. You're going to enter like 0 through 5 in L1. Okay, I guess I could do that real quick. 0, enter 1, 2, 3, 4, and 5. Okay, then we do this trick. We go to L2, you arrow up like you were going to clear, but then you hit enter. When you do that, the cursor shows up at the bottom, and you're going to type this in. Binomial PDF, like we did on the last page. But watch what I'm going to do here. 5, and then 0.15, and then L1. So what that will do is make a whole bunch of probabilities happen. Ready? Here we go. I'm going to go over here. You arrow up so that it's highlighted on the L2. And when I hit enter, the cursor will blink down here. Watch. Enter. And then now my cursor is blinking, and I can type in a formula. So I'm going to hit second and variables and scroll down till I get to binomial PDF. Make sure it's not CDF. We want each individual probability here. How many trials? 5. Probability of success 0.15, and the X value, instead of putting a number here, I'm going to hit second and 1 and put L1. I'm going to hit paste, and it's not going to do anything yet. So look, I'm telling this up here. I want you to go with a maximum of 5 with a probability of 15 and put all of these numbers in and give me all these probabilities. Ready? Watch. I'm going to hit enter, and they'll all fill in. There you go. So let me just point out, I'm going to use my notes so that you see. What's going on here is it just gave me all these numbers. 0.4437, 0.3915, 0.1382, 0.02. It did all of them just like that. Gotta like that trick. You gotta like that. Okay, there you go. Be amazed. Here, I want you guys to make sure that you're, wait, there's my amazed face. It looks angry. Okay. Anyway, hit second. and y equals, and hit enter for plot 1. Turn the plot on. Pick the histogram and make xlist L1 and frequency L2. Let's catch up on the calculator here. I got all my probabilities. I want to see a histogram of this stuff. Ready? So I'm going to hit second and y equals. I'm going to hit enter, and I want to turn plot number 1 on. There it goes. It's on. I'm going to pick the histogram. That's the one in the middle. Good. Xlist 1. Xlist is going to be L1, and frequency will be L2. Mine already says that. If you don't have it, to get L2 there, you hit second and the 2 button to get L2. Okay? Now, I'm not going to hit graph yet because I want to set this window up. Ready? So let me move this out of the way. Don't hit anything. For number 9, hit window. Don't hit zoom for this one. Hit window and make your own window work. The x min will be 0 and the x max will be 6. Look, it's 0 through 5. Let me bring this back here. These are my x's, 0 through 5. So I'm going to put 0 through 6 on the calculator. With an x scale of 1, that's fine. The y minimum, negative 0.01. Oh, excuse me, I'm yawning. That will be just below the x-axis. And the maximum, you guys, look, these are all, they're all decimals. And the biggest one I saw was 0.44, I think. So I'm going to say 0.5. Let me go up here. There are these probabilities. They're in list 2 there. And the biggest one I have is 0.44. So the highest I want my graph to go is 0.5. And the y scale, I'm going to break that down to 0.10. So it goes 0.10, 0.20, 0.30, 0.40, and gets up to 0.50. Then hit graph. So you don't hit zoom. There's no zooming on the calculator in this trick. I set up my calculator by hitting second and y equals. I pick the histogram. I put L1 and L2, but I don't hit graph. I hit window. And then I'm going to make the x minimum 0. I'm going to make the x maximum 6. I'm going to make the y scale 1. That will set up so I have all of my histogram bars. I'm going to go negative 0.01, so I'm pretty much just below the x-axis, and 0.50 is the biggest probability I would ever need to see. I'm going to make this 0.10, so there's a little bit of a scale that's actually on this, and then I hit graph, and there's my histogram. So I don't want it to be perfect in here. I just want to kind of sketch what I see. There's a bar, there's a bar, there's a little baby bar, and then almost like just a flat right there. There's your histogram for 0, 1, 2, 3, 4, and 5 would be so tiny you barely even see it. Okay, the shape. The shape of this is definitely skewed to the right. No question about that. It's skewed off to the right. The center, well, this is a binomial setting. And we have a formula. The mean of x, we learned this last chapter, is n times p. So that's 5 times 0.15. And we did this earlier in the show here today. That's 0.75. And the spread, the standard deviation, is the square root of n times p times q. So in that scenario, it's going to be the square root of 5 times 0.15 times 0.85. We've already done this today, and that is 0.798. There's the shape, skewed, the center, 0.75 for a mean, and the spread, 0.798 for the standard deviation. All right, let's see what's about to happen on the next page. We're going to do the same thing, but this time, it's not going to, that was for 5 days. Now we're going to do this for 10 days. So I'm going to do the binomial setting with 10, 0.15. What I want you to do is change this up so that we can do for 10. So see if you can get this one done correctly. What's going to happen is you change L1 to 0 through 10. So then you got to do step 4 again. And then see if you can pick out a good window. Well, I'll just write it. From 0 to 11 with an x scale of 1 and a y minimum negative 0.01 and the y maximum this time we'll just call it 0.4. The y scale is still 0.1. See if you can get this in the calculator right and see what happens. And then we'll go to the next video.